Hi guys and welcome back. In this video we're going to look at the Day 24 project from the 30 Days of Python series. First of all though, I must apologize if you do hear any background noise or screaming or anything like that. With the lockdown, all the neighbors are outside in their gardens today because it's really sunny outside, so I do apologize if there's any noise. But let's get started with the project for today, and what we're going to be building is a dice roller application that allows us to essentially roll dice, save them into a file, save the results of rolling dice into a file, and we're going to learn a few things about how to work with command line arguments with Python along the way, as well as, of course, gain some more experience building Python projects. The first thing is to revisit why repl.it always runs the main.py file. Up till now, if we create a different file, such as, I don't know, app.py, for example, we've not been able to, run this file. There's no way to right-click it and run it, and there's nothing here. Everything that we want to run in repl.it up until now has been main.py. And so if we do something like hello world and we put it here in main.py, and then we go to app.py and say hello app, and then every time we run the application, we're going to get hello world printed out. So what is going on behind the scenes? Well, repl.it has a configuration file that tells it that when you press the run button, it should run a file called main.py, or rather that it should run a command that is this, python main.py. Python is the command that repl.it is running, and usually when you run the Python command in like a terminal, which is what repl.it uses behind the scenes, then that executes the Python language, and main.py is the name of the file that we want to run. So this here is the command that repl.it is running every time we press the run button. But we can actually change that. We can modify the run button functionality with a file called .repl.it. So it's very important that is .repl.it or full stop repl.it. That's simply the name the file needs in order for repl.it to understand it as something that will affect how repl.it behaves. This file needs to be structured in a specific way. It uses a format called TOML, or Tom's Obvious Minimal Language, which is a common format for configuration files, since it's very easy to write and read. What we're going to write in here is run equal, and then inside quotations, python app.py. Now if we do this, and we press run, you see that we get hello app. And indeed, because we've changed the default configuration, now repl.it tells us what command ran. Here we can see that we ran python app.py. One thing we do with many real-world console applications that run here on a text interface, is we run them with flags and arguments. And these flags are normally used to configure how the program is run, either by turning on certain settings or pieces of functionality, or by providing values for certain options. For example, we can go in here and say python app.py --help. This is a common flag to tell a command line application that we want to get some help with running the application. And normally, when you have a command line application, such as app.py, and you pass in --help, normally the convention is that it will print out a string telling you how to use the application. Of course, at the moment, app.py doesn't really do anything with --help, but we're going to learn how to use flags like that throughout this video. As well as --help, you've got a lot of other things. For example, you can do something like --value equal 5, and this is another type of thing you can pass into command line applications to give them values that they can use internally. So for now though, we're going to stick with python app.py, and we're going to make it so that it can take those flags and arguments. So we're going to do import argparse, and this is the argument parser module that comes with Python. We're going to use it to accept some values from this python app.py command. How we do that is we say parser equal argparse.ArgumentParser. And the thing that we're going to accept is just a number, and this program is going to return that number raised to a certain power. So it's just going to do a little bit of mathematics for us to learn more about how argparse works. So by the way, remember to call this parser. We're going to do parser.addArgument and we're going to do base. This is the argument, and we can provide some help string in here, a number to raise to the specified power. So here we're essentially, if we have a number such as 5 to the power of 3, 5 is the base, 3 is the exponent, and so here we're adding an argument for the base. This is going to allow the caller of the program to pass in the argument base. We can use that argument by doing something like args equal parser.parse args, and that is going to use argparse to actually receive the arguments from that command line script and give us them, and then we can access them, for example, args.base. All right, so if we run this right now, you'll see that we get this. It says Python app.py, but then we get an error. It says app.py error. The following arguments are required, base. And in addition to this, it also gives us some help on how to actually use this application, because clearly we've missed providing base. We didn't do it in repl.it. We just ran Python app.py. And so it says usage is app.py, and then help is optional. That's what the square brackets means. And we have to provide the base. If we want more help, we can do --help, and then we're going to run this, and you'll see that we get some more information. The usage is the same as before. We've got positional arguments, base, which is a number to raise to the specified power, and then we've got optional arguments, -h or --help, that shows this message. You can use short form arguments such as -h, or you can use long form arguments such as --help. Either is fine, but here it tells you which one you can use. So let's use this to run app.py and then pass in the base. So instead of --help, we'll do something like 23, Python app.py 23, and notice that here it doesn't say that we should do --base equal 23. It just says that we put in the base there, and that's the argument that we're going to receive. If we print that, we get 23 back, because our application is receiving the arguments and then it's printing it out. Now we're going to add the exponent. So we'll do parser.add argument, and we're going to put in -e, --exponent, and then a help saying a power to raise the provided base to. So here we are going to provide another argument, and you can see here we're saying that we can provide it as -e or as --exponent, either, just as we have with help, and then we've got a help string there as well. Now if we run this, you can see that because we used the dashes, that makes these arguments optional. So the base is required, and it's a positional argument. -e and --exponent are not required, and they are keyword arguments. So if we go to repl.it, we can say --exponent equal 3, for example. Of course, in order to actually see whether that worked, we have to go and print this, which we will do just now. If I can spell exponent. There we go. So let's run that, and you'll see that we get 3 back. Instead of --exponent equal 3, we can say -e3, and that does exactly the same thing. We get the 3 back here. Notice that we don't need an equal sign when we use the shorthand. A couple other things that we can do with add argument. We can say the type of the value. That way, argparse is going to try to convert the value that we get in, which at the moment is a string, into the type that we say here. So we're going to say type equal float, and in here we're going to say type equal float as well. And we can also provide default values. Because base is required, we shouldn't provide a default value for it, but because the exponent is optional, we can provide a default value for it, which is going to be 2. Now this is getting really long, so as usual with Python code, we can split this into multiple lines, and that's going to be a little bit more readable. All right, now all we have to do is, because these are floats already, or they should be converted to floats, we can simply use them as the base and the exponent, and now we can run this, and you can see that we get 23e3, and that's 12167. We're going to leave a link down in the description of this video for some extra documentation for the argparse module. There's a lot more than you can do with it, so do check it out if you're interested. All right, so now that we've learned a little bit about argparse, we're going to get into the project. We're going to create a dice roller for an n-sided dice. So the user should be able to specify the selection of dice using the syntax that's common for dice, so for example, 3d6. The number before the D represents the number of dice, and the number after the D represents how many sides those dice have. So here we're saying we want to roll 3 dice, each one has 6 sides. And the program is going to roll them and save them into a file and so on. So let's go and do that. Alright, so I have reset this project a bit. We've got the .repl.it file with Python main.py as normal, and I've created a parser.py file that has the argument parser here with a simple description, and it doesn't really do anything else at the moment. We're going to start by adding an argument for the dice. So we're going to go ahead and do parser.add argument, and that's going to be dice, and the help is going to be a representation of the dice you want to roll. We're also going to need 2 optional parameters. These are going to catch the number of repetitions for the roll. For example, if the user passes 1d6 for the dice and then wants to repeat the roll 10 times, then they're going to be able to do that. And the second positional argument is going to be the place for the log file. So our output, our generated output of rolling the dice, where we're going to save it into a file. So here's the first argument. We've got -r-repeat for the number of repetitions. The default value is 1, the type is going to be an integer, and the help is how many times to roll the specified set of dice. Something interesting to note here is the metavar, which is number. That's just going to change what shows up in the help as a placeholder. So if we run this and we run parser.py --help, you'll know what I mean. I'll run that, show you the output. You can see that we get -r number, --repeat number, whereas if we remove this metavar, then we run that, you see that we get -r repeat in all caps. And that's just the default, but we can change that by using the metavar argument if it's something you want to do. Then we're going to do something similar for the log file argument. We're going to add -l or --log. That's the common convention for some place to output the result of a program, a log file. The default is roll_log.txt. The metavar is path instead of, log all in uppercase. The type is going to be a string, and the help is a file to use to log the result of the rolls. So the only thing left to do in this parser.py is to actually parse the dice specification, because remember, this is going to be something like 3d6, and that's clearly not something we can work with unless we understand 3 as a number and 6 as a separate number. And so what we're going to do is we're going to go through the dice and get the numbers in there. So we can create a function, something like parse roll, and we get the args, and we're going to have the quantity and the die size. Remember, the singular for dice is die, and that is going to be equal to the int of the argument for arg in args.dice.split over d. So args.dice is going to give us 3d6. args.dice.split on d is going to give us the 3 and the 6 as 2 strings. And then we're using a list comprehension to iterate over those 2 numbers and convert them to integers. And then we're using destructuring to take those 2 integers and put them into 2 separate variables. And we're going to return quantity and die size. And of course, something that we'll want to do whenever we're doing this sort of conversion to integers is to try things out and make sure that we're not getting any errors when we do that. So we'll accept on value error, and we will raise another value error, but we'll give it a nice message, such as invalid dice specification, and the rolls must be in the format of 2d6. We're going to put from none here so that they get a trimmed back version of the traceback. They don't get the full traceback, which can have a lot of information. If we do from none there, we're going to give a slightly shorter traceback. So let's go over to repl.it, and now instead of help, we're going to do something like 3d6. We're going to run this, and you can see that that's what we run here. We need to make sure to actually run the parse roll function with these arguments as well. So we're going to do that in here just to make sure that it works. Parse roll with args. We're going to run it. We don't get any errors, but if we go to repl.it and we do 3dx, for example, then we will get an error, and you can see here we get the traceback. Invalid dice specification, rolls must be in the format of 2d6. Okay. So let's close this down here. We're going to remove this parse roll in there. We're going to call this from main.py in a moment. So let's go to main.py and import the things that we need. So we're going to import parser, and we're going to import random. And then we're going to do args equal parser.args. That's simply going to go into the parser module and read the args variable that we have here when we parse the arguments using our local parser. So that is going to give us the arguments in there. Then the quantity and the die size we are going to get by doing parser.parseRoll with the args. And the repetitions is going to be args.repeat. And the log file is going to be args.log. So there we got all the information from our parser in one nice short file. We have all the information we need so we can actually start simulating the dice rolls. For a single roll, we're going to use the random module to generate a value between 1 and the size of the die. So we're going to do something like rolls equal random.randint. That's going to generate a random integer between 1 and die size for underscore in range quantity. So here we're iterating over the amount of dice, and we're not using the dice number or the count of dice, but we are generating a value for each dice equal to a random integer between 1 and the size of the die. Then we're going to get the total, which is going to be the sum of rolls, and the average, which is the total divided by the length of rolls. Note though that we have potentially some repetitions, so we are going to want to repeat this code here once for every repetition. So we'll say for underscore in range of repetitions, and we will put all of this in there. Notice that we're using the underscore variable a couple of times. That's totally fine. That just means that we don't want to use the variable anywhere else. It's just there for iteration. And at the moment, we're not really doing anything with any of the results, so let's fix that by writing some functions to take care of the formatting of our results and the writing to our log file. So we're going to create another file called output.py, and here we're going to have all our functions related to the output. So first of all, I'm going to create a simple variable here called roll template. That's going to have rolls, total, and average. We're using the curly braces here because we're going to interpolate values into this template in just a moment. To format results, we're going to pass in the rolls, the total, and the average from our main.py, and we are going to join the rolls with a comma. So we'll do comma.join str of roll for roll in rolls. That's going to give us a comma separated set of values, and we're going to return the roll template format, and then we're going to pass in the rolls, the total, and the average into each of these curly braces. So we'll do rolls, total, average. All right, let's recap here what we've got so far, because we're writing a lot of code and we haven't run our application for a while. So I'm going to go over to main.py and start at the top. We are importing the parser, which is evaluating the passed arguments into our script. And then we are essentially parsing the rolls, which is giving us the quantity and die size for the first argument, which is the dice. Then we're getting the repetitions and where to log to. And finally, we're repeating the number of times the user asked, and we are generating a random value for the dice rolls. We're adding them up, and we're calculating the average as well. In output, we're passing in the list of rolls, the total, and the average, and we are creating this string with those values. So I think it's a good place here to go into main.py, import our output file, and actually use it, for example, to print output.format result with the rolls, total, and average. And that is going to actually make use of these values, show them to us so that we can see that everything's working. Something else that we have to do is go into repl.it and make sure that parser.py becomes main.py. The arguments are still going to be accessible in parser.py even if we run the main.py file, so that's not something to worry about. All right, let's run this. And now you can see that we've got our 3 rolls because we rolled a 6-sided die 3 times. We've got 4, 5, 6, total is 15, and the average is 5.0. We can run this again and we'll generate a different set of numbers where the average is 3.3. Alright, so next up we're going to go back to our output.py file and create a function that will save results to the log file. So we're going to create a function called log result. It's going to take the rolls, the total, the average, and the log file name. And we're going to open the log file, so we're going to do with open log file in append mode as log. We're going to do log.write format result with roles, total, and average. And then we're going to do log.write, and we're going to put a dash there times 30, which is going to give us a very long line of dashes, plus the \n character. That is going to give us a new line. So there we have it. We are essentially going to put a line underneath our results, and the next time that we roll again, we're going to add to this file. Now, if we go back to main.py, as well as printing the result, we're also going to do output.log results with roles, total, average, and the log file that the user passed in. All right, let's bring this back up here. We're going to clear the output, and we're going to run. You can see that this seems to work. We should have a file created here on repl.it. It doesn't seem to be appearing, so all I have to do is refresh, and then it should appear. There we go, we've got rollog.txt, and as you can see, we've got all the dashes, and then we've got \n. It seems that we added too many backslashes here. We're going to go to output.py, make sure that this is a single \n character there, and I will remove that. There we go. Just trying it out. And remember, it's normal to find a couple of mistakes or errors in your code as you go along. You shouldn't be worried about that. Just use it as a chance to improve your code. So now let's go over to .repl.it and change this and try something else. So we'll do 8d10R3, for example. And here we're going to roll a 10-sided die 8 times, and we're going to repeat it 3 times. So let's run this. And you can see we get here the different rolls, and we save these to the file as well, and here we've got all these rolls. We can also use the -h flag or --help to get some nicely created documentation for our command line app that tells us what sort of things our program is expecting. So hopefully you were able to tackle this on your own, but I know it's tricky. You do need to read through the documentation for argparse, and of course you need to know that argparse exists and how to use it, but hopefully this project has given you a bit of information about how to parse incoming arguments to your applications, and that allows you to create more useful command line applications that you can share with other developers, and they can use them in their own way. We'd love to see some of your solutions over on our Discord server. If you feel like sharing, I'm going to leave a link to that down in the description of this video. But other than that, thank you guys for watching. Thanks for joining me today, and I'll see you again tomorrow for the next day of the series.